Hello everyone. This short story is about dynamic taxi route recommendation. I'll take you all through a small flashback about taxi services. In the past, to take a ride, people either go to taxi stand, book by phone call, or wait to take taxi randomly on the roadside. Drivers will have to roam around empty until they get a ride. Most of the time they get in heavy traffic congestion too. Customers, on the other hand, have to wait for longer, and also there was no way to track the location of a taxi. So it was realized that being in right time, right location, and ability to track will increase the probability of getting a ride, and it will also connect drivers and customers well. Then there came the game changer taxi applications, which solve these basic issues, but we all know the scale of impact it has created in our daily life. Ever since the adoption of taxi applications like Uber, Curb, Lyft, etc., drivers and customers are connected really well, and life is much more easier for almost a decade now. Now I will present about how dynamic routes can be recommended for increasing revenue for the drivers. Primary goal is to enhance pickup probability, increase revenue for the driver. A very simple formula, that is to recommend routes to taxi where there will be more currently waiting passengers, less vacant cruise time, more net coming passengers. Technical backend is an adaptive deep reinforcement learning network that works on fusioning of features. This method uses real-time features that implies dynamic route recommendations based on high pickup score calculation for the route. That is, it is not static, it is not based on historical pickup scores for the route. Agent is the taxi sending request for recommendation, and internal features include current waiting passengers, vacant cruise time, estimated net coming passengers for the current location, whereas external features include the same set of features for all the adjacent routes from the current location. This fusioning of features is going to be the magical recipe for this real-time recommendation. This picture is an example to show what we discussed about external features. There are two routes possible from the current location, a residential and a business area. Both the routes' future pickup probability are taken into account for the current recommendation. The master brain of this system is going to be an adaptive deep reinforcement learning method. Agent is the taxi sending the request. The system is going to recommend high pickup probability route in turn with certain state action reward policy. Reward for every state and action will be calculated for better decision making. The steps involved: number 1, taxi agent request for route recommendation. Number 2, candidate route generation. Number 3, feature extraction and fusion of the three mentioned feature sets. Number 4, a deep reinforcement learning network scores every recommended route. Number 5, softmax function to compute the pickup probability for every recommended route. And finally, number 6, route selection is to recommend route with a high pickup probability. Compared to the state-of-art recommendation systems, this adaptive deep reinforcement learning method, along with the fusioning of features, has provided results like increase of about 15.8% of the average earning for the taxi drivers, and reduce at least 29.6% of the average waiting time for the passengers. And yeah, I think miles to go. There will be a lot more innovations in this space. Thanks for listening.